on the board. That's right. It's got a nucleus, a cytoplasm, and a cell membrane. It's got an axon, and some nerves or some neurons have a myelin sheath. What's the function or the purpose of the myelin sheath? That's right. It makes the impulse move much faster. And you need to know that it's another name for the myelin sheath is the neurolemma. Neuroglia or neuroglia.
What? Go back for a second.
Sorry.
Okay. Okay. Oh wait, take your hand.
What?
Yeah.
Oh, you got it? Okay, so the other day let's see, we talked about the different neurons. I didn't talk about what neuroglia was, I don't think. It's the supporting structure for nervous tissue. It's like a spider web, and it's got different cells like different, I don't have a very good definition. It's a supporting structure of nervous tissue consisting of a fine web of tissue around nerve cells or neurons. Okay? So think of a neuroglia as a spider web. Alright? Eddie, what is the difference between afferent and efferent neurons? Yes, remember we talked about it in a way for you to remember? Anybody remember? Okay, afferent neurons are sensory. So if you've got something being sensed, like you can sense something, that is afferent, an afferent neuron. Motor or efferent is neurons that make your neurons do something. All right? Let's see, different way to explain that. Motor. We have to have muscles to move us, right? Well, neurons have to have an impulse to make that muscle do something.
So like feelings and action.
Yeah, exactly. So if you feel something, you're sensing it, you feel like your hair stand up on the back of your neck, maybe if you sense something, or you brush by something and you sense it, like the little hairs on your arm. You guys get it? Huh? No? Nobody's saying here.
Kind of. I don't know. Like I do, but yeah, I do.
You
Well,
okay?
Me? Yeah.
Did I have a bad day?
Yeah, she's having a bad day. I don't know. Sitting on camera.
Oh, okay. Alright, so just remember that afferent neurons send signals to the brain. Or another way to remember it is away. Send signals away from the sense. Okay, to the brain or away from the sense. The sensory neuron. Oh my goodness. Motor or efferent neurons come from the brain to the motor, to the muscle that is going to make the motor movement. Okay? Haley? You get that?
Yeah.
No, not really, or yeah.
Yeah, it sounded good.
Megan, you get it? You can say no. Eddie?
Yeah.
Okay. Alright, so membrane excitability, you can have an impulse makes something move or sense. Alright, we were also, where we stopped, we were talking about a synapse or an impulse. A synapse is when the message goes from one to the next. The synaptic cleft is the space between the axon or the end of one cell and the beginning of another, which is the dendrite. For the test, you're going to have to know the axon to the dendrite. Okay, that space is the synaptic cleft. There are neurotransmitters in that space. Do you guys understand what a synaptic cleft is now, Lauren? Huh? What? Whoa, go back. Please. All right, Haley. Tell me what the synaptic cleft is. Lauren, what's the synaptic cleft? Okay, which comes first? The axon or the dendrite? The dendrite, that's right. The nervous system can be broken down into two things. The central nervous system, which is what we're talking about today, and the peripheral nervous system, which we'll talk about, of course, later. The central nervous system is the brain and the spinal cord. That's it.
Tower over everyone.
when we get to the chapter on the PNS, or peripheral nervous system, we'll talk about what the autonomic nervous system is. But you can kind of look at autonomic and see the AUTO. What do you think auto means? Not truck or vehicle. Self. Very good. So the autonomic nervous system, you don't have to worry about. Your body does not have to tell to do it. It's like your heartbeat. It just does it. All right, some effects of aging on the central nervous system. It slows down nerve conduction, so they can't do things as fast because the impulse, the transmission between the axon of one cell and the dendrite of another is slowed down. They don't conduct that impulse. You also decrease your brain size. So it's got a lot of water in your brain, and it shrinks in size. Don't close it all the way, please. Thank you. I was going to say, the brain size. Your brain's made up of so much water. If you were to take out a brain from someone's skull and place it on a table or a hard substance, like a table, it would ooze down and flatten out. So the only reason it stays in its shape is because of the skull that's holding it. In our video, DVD, the Body Worlds, it talks about the plastination process. And for many years, they had trouble getting the brain plastinated. They couldn't figure it out because it was made up of liquid. So I don't know what they eventually did, but they figured it out. Your reaction time slows. What's one reason for that?
Because your nervous system doesn't send up sparks to tell you not to, or to react to it, isn't it?
What about the spark or impulse?
Isn't it a slower time?
Why? I mean, do you have anybody have a guess?
Say the question again. A guess on what?
Why would an impulse be slowed down?
Yeah, nothing.
What is an impulse? Or a synapse?
Wait, they're the same thing?
An impulse and a synapse, yes.
How can it get slowed down?
Myelin sheath, very good. That's one way. Tell me again, what's a synapse?
Yeah, between the dendrites and the axons.
Wait. What did you say, Megan? That's right. A synaptic cleft is what? Heidi, what's a synaptic cleft?
Oh, it's between
Very good. All right, so a synapse is one message that goes from one neuron to another. So what could happen?
It has to do with something with the cells.
Could? Yeah, Okay, good. What about if it's the synaptic cleft gets further apart? Would it go as fast?
No.
No. dendrites, maybe? Okay. Alright, also, changes in sleep pattern. When you get further and further in age, did you guys have any examples? I mean, think about your grandparents. What time do they usually go to bed? Do you have any idea?
8, 9.
8, 9? Okay, what time do you think they get up?
My girl gets up at
6.
5, 7,
5, 6, 7. What time do they eat supper?
12.
4, 5.
4, yeah.
Sometimes 11 because my grandma's from
A lot of times they go to bed earlier, they get up earlier, they eat supper earlier. It's kind of fun. One day we went to dinner early and we went out to eat and it was like 4:30 and everywhere we looked there were elderly couples or elderly people and it was just, anyway, next time you might notice that. Alright, so as you get older in age, your sleep pattern changes. Alright, this is something you need to know. The brain of a human weighs about 1,400 grams or 3 pounds. If you do an autopsy and the brain weighs more or less, it can signify something. Dementia, or if you have Alzheimer's, it is a form of dementia in that your brain shrinks. You don't have as many convolutions. So if they weigh your brain and it only weighs 800 grams, that can tell you, oh wow, something's going on here. Why is it weigh so much less? I mean, dehydration. You don't have the water there. That's one way that, you could be low on brain weight. I think that would be a funny joke. Somebody said, how you did today? Well, I'm a little slow, or my brain's a little light today. You think that was fun? It's okay. Heard that, Haley. 100 billion neurons. 100 billion. Is that a lot? That's a lot. Meninges. Your meninges are, well, I'm not sure how to explain a meninge. I'm going to skip that for right now. If you have meningitis, you can't put your chin to your chest.
So it shrinks the spine instead of...
You're making a really weird noises.
It shrinks.
Well,
No,
it shrinks the
it makes your neck frigid, and you can't bend your neck.
Okay. So it kind of like, it makes the spinal less flexible.
Well, you're just in your neck, and that's the #1 sign, oh, there's a big problem. Meningitis, there are bacterial meningitis and also viral, and I don't remember which. I think it's viral that's really serious and bad, deathly. But cerebrospinal fluid, or CNS, central nervous, CNS. CSF, sorry, I knew that wasn't right. CSF, cerebrospinal, there's the S, fluid, F, cerebrospinal fluid, for short. That is a substance that's in your brain. brain, and it's in the ventricles. You have 4 ventricles, and those ventricles contain that fluid. And you guys remember seeing the picture of the infant that had a huge skull? Remember seeing that? I showed, it's called water on the brain, or not elephantitis, water on the brain, encephalitis. I am doing a lot of mistalk. That is because that CSF is not being drained. It's supposed to be in the ventricles and then go down your spinal cord and then into your abdomen. But if it does not flow or drain from your brain, your skull has to enlarge. All right. Another thing about the brain is without oxygen, you can have brain damage within 4 to 8 minutes. So if anybody, goes down, you need to be able to start CPR. What's the reason? Anybody have an idea about CPR? What is it about CPR that saves somebody? You guys know? What is chest compressions? What does that do? Pumps your heart. What do you mean by that?
Like your heart stops beating, and so they start beating your heart for you, so it circulates.
Circulates what?
Your blood,
The blood.
which carries oxygen.
That's right. So doing chest compressions pushes the heart, squeezes it closed, and then as it opens, it sucks in all that blood. And then, like a sponge, you can squeeze the sponge empty, rinse out all the water, and then let off of it, and it absorbs the water again. Well, it's the same thing with the heart. When you press on it or do compressions, you're pushing out that blood so it keeps going where it needs to go. It keeps getting to the brain. It keeps getting to the other parts of the body. Oh, you guys are killing me today. All right. Ashley, what is CSF? Rachel?
Spinal fluid.
Okay. How many minutes until with your brain without oxygen can there be brain damage? Michelle?
48.
Good. Thank you for paying attention. What is the central nervous system composed of, Alejandra? What's the central nervous system composed of?
The brain
Good. What's the other branch of the nervous system, Allie? Megan? The what?
You're talking about the
Peripheral nervous system. What makes up the peripheral nervous system, Lauren?
pairs of cranial nerves, cranial nerves, spinal nerves, autonomic nervous system.
Very good. What does autonomic mean, Eddie?
It's on its own.
Good.
Flagon.
What, Eddie? She didn't hear you.
Does it on its own.
On its own.
What's the synaptic cleft, Haley?
Space.
between.
With space between what, Heidi?
Roses. In the picture. So that, I don't know what that is. I just draw it. So that one. So this would be dendrites and
Thank you.
thanks, Heidi. You're welcome.
What is between, or what is what's between the dendrites of one neuron and the axon of another one, Heidi? What's
The synapse? Or
okay? There's a word that I'm trying to get you to say has things that are in the synaptic cleft.
the neuro.
Very good. Neurotransmitters.
Oh, you forgot to write the rest of it.
Yes, I did.
It's actually right there on the screen.
Yeah, I saw that after I looked at it.
What makes up a neuron, Megan?
Thanks. That too. I forgot to put this.
Here. How come?
I just don't know.
Where's your notes?
I don't take notes.
What was the question?
Can we go back? Or are we continuing to go forward?
What?
No,
What was the
I
question?
just want to get the other slides.
What makes up?
A neuron. What is it composed of? Okay.
And then it's got your cell membrane and your nucleus.
Very good. All right, we drew a picture on the board the other day. What does a neuron look like? What does it have?
Looks like a hand.
It looks like a hand, okay?
Jackie said it was a chicken foot. It was
A chicken
dendrites,
foot?
Yeah.
axon.
Jackie
Wait.
said it was a chicken foot.
All right.
What was the other part of that question?
I think that was it, wasn't it?
Oh, I thought you said something. Was it composed of something?
Lauren answered that one. What's it composed of again, Lauren?
Nucleus, cytoplasm, and cell membrane.
Very good. Okay, I want you to tell your neighbor something new you learned today.
We don't read a long time, like,
What is it composed of? Oh, the synapse.
yeah, brain.
Oh, yeah, the
I was gonna stop by.
Megan, did you want to talk? Yeah. What'd you talk about?
I said,
Hey guys, listen.
if people breathe 4 to 8 minutes,
Good. What's something you learned today, Brittany?
our brain weighs 1,400 grams or 3 pounds.
Megan P., what'd you learn today?
What are 100 neurons?
Ashley, what'd you learn?
Nothing.
So you already knew it all?
No, I didn't learn it.
How come?
I just didn't.
Are you taking notes?
Nope.
Why?
I don't ever take notes.
So what are we gonna have to do to help you learn it?
I don't need you to do anything.
Are you having a bad day? Rachel, what'd you learn today?
The brain damage occurs within 28 minutes.
Do what?
Without oxygen, the brain damage occurs within 48 minutes.
You can go on.
Do you guys have any more that you need to do?
Megan already said that one.
They're more parents on the spiral nerves.
Good. Alondra?
Brain worms.
Somebody already said that one. Brittany did.
Develop oxygen. Happy birthday, Ellen.
Today's your birthday? Happy birthday. Michelle, what'd you learn today?
That there are 12 pairs of hands.
Good. We're going to learn those. You're going to have to know their names. Not today, though. And there's a way to learn them in the order. Hello.
Can I get the synapse part?
Can you what?
Get the rest of the synapse.
When they leave.
Okay.
We're going to talk about the parts of the brain. The cerebrum with the BR, that's what would you close the door, please? That's a way. Gotta go back to the bus. Yeah.
I forgot my things. All right.
Are we doing? Sorry. Are we doing a teaching project? Okay. Fun. Because I didn't even get to finish it.
The cerebrum has a BR in it. Remember, a way to remember the cerebrum is that's what you look at if you think about the brain. That's this part right here with all the convolutions, the twists and turns, the valleys and mountains. You're going to learn about what they're called, and you're going to have to know that for the test. But a way to remember cerebrum has a BR, and think about that's the actual brain. The diencephalon we'll talk about. It has two things that make it up, and you can remember that because of di. Di means what? Two. The cerebellum is a little bell-like. You guys want to turn around and look at this? This is the cerebellum, right back here. Megan, Haley, what? This is the cerebellum. It's like a little bell underneath the cerebrum. This is the cerebrum, this is the cerebellum. Okay? And the brainstem, actually the diencephalon is on the brainstem. And this is the brainstem. It is a stem, like a flower. This is your brainstem. Alright, so what's this called? Hey, Allie?
The brain.
This part?
That's half the brain.
Cerebrum.
Cerebrum.
Okay, what's this part called, Colby? Looks like a... What? That's right. Haley, what is it? What's this part called?
Cerebrum.
You're close. Higher?
Cerebellum.
Cerebellum. How are you going to remember that that's the cerebellum?
It looks like a bell.
Jessica, how do you know a way to remember this is the cerebrum?
And it's big.
Because of the BR for brain. This is, you think about your brain, and probably this is what you think of. So what is it by Colin, Brittany? Why do you not have a clue?
So not here big.
Jackie, what's this part called?
Brainstem.
Brainstem. Thank you.